Now, could we have found this information out by just reading RGB numbers? Certainly, but it would have taken 2 or 3 times as long because we would have had to process a lot more information because the RGB numbers give us some darkness information that's really not useful. In looking at the hair, I really don't care how light or how dark it is. I just want to know that it's not green. And by looking at the AB numbers, that gives immediate feedback that something is wrong and it needs to be corrected. In this case, we would just call up the curves, darken the green channel, and we have to assume that this is going to make the picture look better. Command Z, and you should now be able to see what might not have been visible before. There really is a green cast in the shadows that's made considerably better by just being aware that it's there and fixing it with a simple adjustment. Okay, and with this, we can now go on and study what the actual LAB channels look like. Okay, we're in LAB here, and let's pretend, though, that we're analyzing the picture with the idea of correcting it, identifying casts as we've done before. Okay, the sky, -5, -17. Okay, well, the sky is blue in the B channel. It's a little bit on the green side in the A channel. Suspicious, not necessarily anything wrong. Okay, the white part of the flag here, +1 and 0, so that's very close to being neutral. Here in this part of the stripe, we're +5 and -11. -11 means that's fairly blue, but the +5 is somewhat on the magenta side. Now down here in the grass, we get -10 and +55. -10 is a bit more green than it is magenta in the A channel. +55 in the B, that's way, way yellow. If this were truly a green, I would expect the B value would be about half that. So this is not really good color here. This is too yellow, but the flag, it seems, is too blue. Now, so we have therefore the kind of conflicting color cast that's very difficult to fix in LAB. We'd want to do that in RGB, I think. But as long as we're in LAB, let's just take a look at what the channels are like. There's no real difficulty understanding what the L channel looks like. It's going to be a black and white rendition of the document. So I'm going to do a Command 1, the keyboard shortcut, Control 1 on a PC. That shows the L channel, and isn't that about what you would expect if you converted the file to black and white? Okay, there's the color version again. Now what does the A look like? It's going to look like a blur. Furthermore, it's going to look like a gray blur. It can't possibly show white or black because a white or a black would represent a color so far out of gamut that it's very likely your monitor would explode if it tried to display it. Nevertheless, a lighter gray is going to represent something that's more magenta than it is green, and a darker gray something that's more green than it is magenta. So I would guess that these areas, the white stripes, being relatively neutral, they're going to be pretty much a 50% gray. But the red stripes, being much more magenta than they are green, they're going to have to be lighter. So we expect sort of the weird result that the red stripes, which we consider to be darker than the white stripes, the A channel considers them to be lighter than the white stripes, as shown here. That's the A channel. Command 2 is the shortcut. And yeah, this here, where the cursor is, that's the red stripe. And yet it's lighter in the A channel than the neutral stripe. The rest of the picture in the A channel is kind of flat because there's not too much outside of the flag that has a big magenta or green component. Let's switch over to the B channel now. There we're seeing a little bit more drastic action. The bottom half of the picture is rather light because we saw that the greenery is actually way too yellow. The blue background on the flag behind the stars, of course, this is fairly dark. It's much more blue than it is yellow.